Welcome to the Rich Report, a podcast with news and information on the world of big data. Today, my guest is from Continuuity. We have the CEO of the company, Jonathan Gray. Jonathan, welcome to the show today.
Thanks, Rich. Thanks for having me.
Well, thanks for coming on, Jonathan. I've read about Continuuity in terms of big data, but I thought we should get acquainted and maybe start with your slide deck and then follow that with a Q&A. How's that sound?
Great. So I'll dive in here. So looking at the first slide with Continuuity. So we're a big data company. We're based in Palo Alto. We've been around about 2 years now. The background of the company, I came out of Facebook and some other startups and HBase committer and in the Hadoop community. And that's kind of the breed of our engineers. A lot of internet company people, early adopters of Hadoop, companies like Yahoo and Facebook and LinkedIn and Google. We're about 24 people now, so we're growing and hiring, of course. And we've raised about $12.5 million from some really top-tier VCs, Battery, Ignition, and Andreessen. And we have a great network of angels that support us as well. So looking into the next slide here, let's talk about what we're actually doing. So we have built what we call the industry's first big data application server, and we call that the Continuuity Reactor. So the reactor is built on top of open source Hadoop technology. So you can see here in the diagram, we have our app fabric and our data fabric. The app fabric is the scale-out runtime, and that's based on Yarn, or Hadoop 2.0, as well as a open source project that Continuuity released a few months ago called Weave. Weave is available up on GitHub. We actually just submitted our Apache incubator proposal, hoping to get that into Apache. It basically makes building applications for Yarn much simpler, much higher level. So instead of 1,000 lines of code, it's more like 100 lines of code. It really reduces a lot of the boilerplate stuff. And that's kind of indicative of what we're trying to do more broadly as a company, which is abstract away some of the complexity of the very low-level nature of Hadoop and Yarn and HDFS and HBase, and provide more developer-friendly, developer-centric APIs, and provide the kind of tools and lifecycle management that you need. And so, there's the app fabric. It's the scale-out runtime based on Yarn and Weave. And then we have our data fabric for persistence storage, and that's based on HDFS as well as HBase. And HBase is where a lot of my background has been. On top of HBase, we've built a transaction engine as well as a high-throughput queuing system. And we use that to power another piece of technology we have called BigFlow. And BigFlow is a real-time stream processing engine. It's analogous in some ways to Storm and S4 and other open source things out there, but it's quite different in that it's transactional and durable and tightly integrated with HBase. And so whereas Storm and these other systems are in memory, BigFlow is very persistent and transactional, but also high throughput. So we have our app fabric, we have our data fabric, and that's really the underlying infrastructure of our system. But the way as a developer that you actually build your application is using what we call our platform capabilities, and that's the box above. And so when you build your big data application using our big data application server, you do these four things. You collect data, you process data, you store data, and you query data. So collection is how do I very easily ingest data in real time or in batches from any different source. And so we support REST. We also support Scribe and Flume and Kafka and other types of protocols to make it very, very simple to ingest your data into the platform. Once you've ingested it, we provide different ways to process it. Primarily that's through traditional MapReduce on Hadoop, as well as BigFlow, our real-time stream processing system. So you can collect your data, you can process it in batch, you can process it in real time, and obviously then you need to store that. And so whereas on the collect side of it, you're really just collecting raw data, kind of unstructured raw data like what you would imagine is in HDFS. Store is really about indexing that data and storing it in different ways, oftentimes in HBase. So I may want to, ingest raw tweets and perform some real-time sentiment analysis on them, but then I actually want to, write my results down. I might want to store the tweets. I might want to store aggregations about what the sentiment is over time and things like that. And that's how you store your data. Lastly, you query the data. You want to get it back out again. You can make just simple REST calls into the HBase tables, or you can also write something we call a procedure. And procedure is basically server-side logic that you deploy into our platform and allows you to run any kind of arbitrary logic on top of all your data sets. So we have a set of Java APIs that allow you to build your application using these 4 different types of capabilities. And then we expose it to you in different ways. So we have our development kit that's available free download from our website. We have our gateway. That's how you ingest data in and out. That's also how you access things like deployment and lifecycle management and metrics and logs. So, and then we have our DevOps dashboard, which is a user interface that allows many of the same things: deploying, lifecycle management, controlling scalability, and looking at metrics, looking at logs, all that kind of stuff. Now, that DevOps dashboard is actually built wholly on top of the REST endpoint available from the network gateway. So it's very easy to integrate our platform with other systems, other platforms, things like that, because everything is available via REST, whether it's data ingestion and data querying, or it's actually looking at the metrics and logs of your applications. So it's kind of a high-level overview of the platform in itself. And looking at the next slide here, we can kind of see how that manifests itself in our different products. So we basically have 2 products that are free and targeted at the developer, and 2 paid products. So our Reactor Development Kit, which is in public beta today, and this whole 2.0 release that we're talking about is the non-coming out of beta version of that. So we have that. This is a fully featured development kit. It includes what we call our local reactor. So the local reactor includes an emulated version of Hadoop and HBase. So it's very stripped down from the amount of code that it uses, but it's fully functional. And so it's very easy to just download our software, start the thing on your laptop, and start developing locally. We also give our whole SDK, all of our tutorials, example projects, documentation, command line tools, the user interface, all the different things you'd expect to be in a development kit to really get a developer going on top of Hadoop very, very quickly. So that's available for free from download from our website. And we also have available on the website our developer sandbox. This is a free self-service 30-day hosted cloud environment where you go hit a button on our website and we spin up a virtual machine in a public cloud. We deploy a special version of the reactor, a 1-node version of the reactor, and you then get access to that. And so this enables you to take some of the apps you've built locally and actually deploy them into the cloud and let them run for continuously. So those 2 we offer free to the market, really oriented at the individual developer. When you're ready to go into production, we have 2 different forms of that. One is in the public cloud and one is on-premise. So we have our cloud reactor. Today this is a single tenant public cloud PaaS, fully integrated big data app platform. This includes Hadoop and HBase and Zookeeper and all the other Hadoop ecosystem technologies. And this is hosted and operated by Continuuty's ops team. So if you're a smaller company or you don't have operations, you don't want to get expertise in Hadoop and managing of Hadoop, then and you don't mind being in the public cloud, then that's the cloud reactor. The enterprise reactor, which is actually where we get a lot more traction today, is on-premise. So this installs over an existing Hadoop 2.0 cluster. And really, we still consider it a PaaS, but instead of it being a public PaaS, it's really an internal development PaaS. And we really enable a large enterprise company to stand up a reactor inside of their environment and have a internal development platform, a single unified development platform for all their application development on top of Hadoop. And in that case, your operations team runs that along with your Hadoop cluster. So what are we actually trying to solve for companies, and what's our value proposition? So if you jump to the next slide, it's pretty simple. We're really slashing time to business value. This is all about saving time. We make it very easy to load your data, and we make it very easy for your developers to focus on the problems they're trying to solve rather than comprehending and wrangling the underlying infrastructure. We really enable you to build things very, very quickly, and we enable you to learn how to do it very quickly. So we've really lowered the bar in terms of how much you have to understand about Hadoop in order to effectively use it. And we've also created tremendous amounts of reusability, tremendous amounts of tooling and things like that to really aid in what we call the application development lifecycle. A developer sits down in their IDE, they build prototype, they then want to test it in a small environment, then they want to push it into a staging environment and eventually into production. And our PaaS notion, along with our local version, make that very, very simple. You develop it on your local machine, you hit a push to cloud button, you point it at the right cluster, and it will ship your application up to that thing. And so a very seamless PaaS type of experience, even when you're on premise. You don't have to involve a whole bunch of different members of your organization each time you want to put a new app online. We also give a bunch of pre-built building blocks we call data sets and application patterns. So if I want to build an OLAP cube on HBase, or I want to store time series data in HBase, we provide data sets, and all you have to do is use their API, and we've done the hard work of customizing and managing the schema in a performant way on top of HBase. Application patterns go to the next level, which is, okay, I want to do sentiment analysis on text, or I want to do anomaly detection across streams of network data. We provide some reusable building blocks that have not the be-all, end-all best algorithms ever, but what we find in machine learning is the 50% solutions really get you a lot of the way there. And so that's what we provide is if you want to do these things, we give you an out-of-the-box way to put this all together quite quickly. On the cloud side, obviously, we can drastically reduce the amount of cost associated with big data development because we can take away the operations side of running Hadoop for you. And I think probably, I mentioned it a little bit, but the ability to leverage the talent that you have is really, really one of the value propositions that has been played back to us by our customers quite frequently, which is it's very, very hard to hire a Hadoop developer, very hard. If you're, on the East Coast, it can be extremely difficult. And if you're in Europe, it can be near impossible because there's very few of them. And so how do people use their existing talent? And one of the other problems that we see is people home grow their own Hadoop talent, and then 2 years in, they leave because they're being offered a ridiculous salary at some Silicon Valley startup or some big traditional company who's just paying over the top to get this talent. And so it's really hard for all these companies who want to use Hadoop to actually get the talent they need to use it. We enable your existing Java development team to become very productive, very effective on top of Hadoop in days to weeks rather than months and quarters and years. So we really lower the actual gap towards how much you have to learn about, make it a much, much simpler, more integrated and seamless experience. And so we can get your talent trained up, the talent you already have, in a matter of weeks. So that's kind of the company overview. And what we're doing right now is announcing our 2.0 release. So if you could jump to the next slide here on 2.0 highlights. So this will be our first production-ready release of the Continuuity reactor. We've really been focused on the performance of our system, the production aspects of it. So, in some sense, being complete enough from a feature standpoint, you can actually put it into production. And then, of course, having the reliability and the scalability to be in production. And lastly, what we call our developer experience, which is what is it like to be a new developer on our platform? What is it like the first 15 minutes from when you download our development kit? And how long does it take before we can make you productive on top of our platform? So we're really focused on those things. So scalability and performance, all that has been a big, big part of it. We're working on very, very large-scale production types applications. And then we've added a whole bunch of new features as well. So originally, the version of our platform only had our real-time streaming capabilities. We've also added batch and the ability to unify those two things across the same data in the same cluster. We've added a basic workflow engine. This allows you to schedule jobs. This allows you to create very basic kind of series sequences of jobs. It's not a full-blown workflow. But this is one of those features that we kind of decided, we need a basic thing to be able to be production, because the ability to schedule jobs and the ability to at least change some jobs is just really a critical aspect of many, many applications. So we built out the basic workflow for 2.0. We also have our resource view and our metrics explorer and our log viewer. So what resource view does is it plugs into Yarn, and it gives you a view of how many containers am I using, how much memory am I using, how much is available, how many CPUs am I using, and how much is available, and across my applications, where is that utilization coming from? And the metrics explorer and our log explorer provide a way within our user interfaces to explore your custom metrics. So when you build applications on our platform, you're able to emit whatever metrics you want, all your own custom application metrics. Those can now be explored through our visual metrics explorer on our user interface. And around the scalability and reliability, we've also added a tremendous amount of scalability and high availability for our gateway, the data fabric, and the app fabric. So all of those are very scalable and highly available today. And our last kind of big announcement is we're announcing our strategic partnership with HBase. So we are adding support for OpenStack, and they will be featuring us in their cloud marketplace or Cloud Tools marketplace. And then when you deploy your big data apps, you'll be able to start your sandbox reactor using the HBase cloud. So we'll enable developers to build big data apps against the HBase cloud through our sandbox reactor. That's a partnership we're really, really excited about. They've been a great partner, and we really both care a lot about developers, and so it's a great fit. So on to the next slide here. Kind of talked about some of these already, but I'll do one last little overview here. So on our 2.0 features, we have support across many versions of Hadoop, all of the 2.0 versions, so the different branches of CDH4, the different branches of HTTP2, and all versions of Apache after 2.04. Again, we've done high availability across everything inside of the reactor. One customer-driven requirement was our Kerberos integration. So we're now integrated with HBase, HDFS, and Zookeeper's Kerberos. So you can actually use secure Hadoop and stuff from Reactor. In conjunction with the resource view and with Yarn, we're integrating with LXC, Linux containers, and C groups to provide process-level resource isolation. So when you deploy your MapReduce jobs in our platform, or you deploy your flows or your procedures, we start those inside of Linux containers with C groups, such that we have very fine-grained resource isolation between all the processes. And so you can start anything and say, I need 1 gigabyte of memory and 1 CPU, and we can control that very distinctly. Just moving along here, RESTful APIs across everything, performance. We've done a lot of different things with performance, doing a lot of stuff on top of, throughput on the range of the Twitter fire hose, which is about 20,000 tweets per second, and then being able to do deep analytics, machine learning, and natural language processing on that scale of data, but with data consistency the entire time. And then the last thing here I'll mention is our support for web applications. So one thing that's very common when people are developing apps for our platform is there's a front end, and it's usually the only thing that doesn't actually live in Hadoop. And so what we've added is a way to actually deploy that web application into Hadoop. So we use Yarn and our app fabric to deploy your web applications inside of the reactor. And then we deal with all of the routing of requests and stuff, such that you can serve your static files off of the same endpoint that you can hit to access the reactor. Really simplifying web development and making it so that you can do everything within your Hadoop cluster. So last slide here. We released something on October 22nd. Called Streamy Lite. So Streamy was my previous startup. It was a real-time RSS aggregation social system. And it's actually how I got into Hadoop and HBase in the first place. Was we had a ton of big data type problems, large scale, and got into Hadoop in 2007 for Streamy to try to migrate our platform. And we did that, and that's how I got into HBase development, because it really wasn't ready for us to do that. So it's been an interesting exercise. Basically what we did was, we really wished back then that Continuuity existed. It would have made our lives much, much easier. And so we went through this experiment really to dog food our product, to say, what would it be like to rebuild Streamy on top of Reactor? And so we did that, and we released it to the public, lite.streamy.com. You can go there today. And eventually we'll be sharing more about how it works. We'll be sharing the code and adding a lot more features, and really using this as a way to showcase the platform, and as a way for our internal development team to dog food, to actually be a developer on our platform building applications. This took about, I think it was 40 hours to do the initial version of this, compared to about 4,800 hours the first time around.
Terrific. Well, question, Jonathan. I was going to ask you more about the genesis of this. Did
Yeah.
you guys see a big gap where you saw that if you could deliver this kind of platform without all the complexity, that there was a lot of money to be made, or what were your thoughts there?
Yeah, I mean, so I've had a lot of experience as a application developer on Hadoop. So at Streamy, we moved the entire platform on top of Hadoop and HBase. And when I was at Facebook, that's all we were doing. We built Facebook Messages, an analytics system called Facebook Puma, and a bunch of other projects there. The focus was not on the infrastructure. Hadoop is the enabling technology. The problems we're solving are in the application layer. And what I saw at Facebook and what I saw at Streamy was, slightly different things, but in both cases, two things happened. One, the developer is working at the wrong level of abstraction.
Yeah.
Hadoop and HBase are really low level. And so what happened at Streamy, what happened at Facebook is you start to build your own middleware. You start to build a data API that abstracts your application from the underlying storage. And so you kind of naturally, the big installations of HBase that I've seen usually have some kind of middleware. And the problem is, to build that middleware really requires a lot of expertise about HBase. And so you have this big gap where I need to basically totally understand how Hadoop works. I need to understand how HBase works from an architectural perspective. Part of the problem is they bleed their architecture into the API. You actually have to be aware of how the system works to be able to effectively use the APIs.
Yeah.
That's just not right for a developer. The kind of just enterprise Java developer who understands, Spring and Hibernate and J2EE really should not need to understand how does a distributed hash table work. They might understand, need to understand kind of what it does, but why do I need to understand the nature of its distributed algorithms? And why do I need to understand how data gets placed on disk versus how it gets located across nodes? And, there's just a lot of complexity in how those systems work. And to use them effectively, you have to understand that complexity. And what we're trying to do is to say, you know what? You can actually build this middleware once and for all. And you can actually raise a level of abstraction and really focus around, what I see as doing what open source is not good at. Open source is really not good at creating seamless experiences across many, many different projects. It's not good at documentation. It's not good at example projects. It's not good at user interfaces, documentation, tools, usability, right? Open source, to me, has proven to be terrific at infrastructure, at hard, low-level problems where putting huge teams of QA on it and putting a bunch of different use cases against it drives tremendous value for that project, right? I think Hadoop is a great kind of example of that. Is all different types of users, the big users of Hadoop, have very different use cases, and that's pulled Hadoop in all different types of directions. And so you see Hadoop being used purely offline in some places and purely online in other places. And that's actually a great thing for the technology because Hadoop can now deal with all that different stuff, and so that dynamic nature of the community helps to make it more generalized. Now, it's very generalized, so it means it does a lot of different things. Inherently, that means you have to do a lot with it to make it work. And so I think it's kind of the gift of open source and then also the curse of it, which is by being so broad and by being so generic, you can do a lot of different things, except it puts a lot of the onus on the user. How do you raise that abstraction? How do you take the onus away from the developer and to just give them something they're more familiar with? More like J2EE patterns, more like Hibernate, higher level.
Yeah.
And then I think, the other thing about the Hadoop community is there's a lot of different projects. right? It's a broad set of technologies. And if I want to, build my company, my startup on a NoSQL database, well, is my first step to get an education in NoSQL databases so that I understand all the various trade-offs between all these different things? I mean, to me, that sounds a little bit onerous, right? I want to be focused on my startup, not on understanding NoSQL databases.
Right, right.
And that's what we're trying to do, is enable people to focus on their problems rather than on the infrastructure. That's just really an enabler.
Yeah, and we see the results there. You went from your original shot at that project, 4,800 hours of development to 40. Um, that's a great use case.
Yeah.
We're running short on time, Jonathan. But I did want to ask you, how easy is it to kick the tires on this? Because
It's
that's
super
key.
easy,
Yeah.
easy to kick the tires, especially with our new 2.0 release. So you go to our website. We do ask you for your email address, but other than that, free download. You just unzip this thing on your laptop. You hit Continuuity Reactor Start. You can start deploying some of the sample applications, or you can open up those sample apps in your IDE and just start looking at how the code looks. We also have, a PDF in there, which is a very detailed development guide, everything from the architecture of the system to the APIs to example projects. Everything is very, very well documented.
Hmm.
And there's a kind of real slick user interface that sits on top of all that. So it's very usable, very easy to get started. Hit the website, download the developer kit, and get it running on your laptop.
Well, terrific. Well, Jonathan, this sounds like a great progress for you guys with 2.0, and I wish you the best in the future.
Thanks a lot, Rich. Really appreciate the time today.
Well, you bet. Well, thanks for coming on. And that's it for the Rich Report, folks. Stay tuned for more news and information on the world of big data.